After that, I will host it on YouTube as unlisted. So only people who have access to the link will see it. Also, so machine learning deals with a lot of mathematics because the reason is that it involves a lot of statistics, mathematics, and computer science related stuffs. And all of them also relies on mathematics. But then we don't need to know these heavy mathematics to understand what machine learning actually is at our level. So we cannot do away completely with the mathematics. Definitely some terminologies may be mentioned and definitely we need to know at least basic of them. Now, this part is very important because in the ground they may ask you, machine learning pick its motivation from what we call data science, and machine learning also give way to what we call AI. So without data science, we can't have machine learning, and without machine learning, we can't have AI. So it's from data science, machine learning, AI, deep learning, so on and so on. Now, data science, even though the lecture did not mention it, but I'm trying to mention it so that you get the overview. Because you can't study machine learning without knowing anything about data science. So data science involves much of mathematics stuffs where you have a data set. You make sure that the data set that you have is being prepared for the actual thing you want to use it for. In on this level, we may be using few data sets, but in the practice, you may use about millions of data sets, a large sample of data sets, which you need to engineer it very well before you can start using it to prepare or put it to any algorithm. So we have data scientists, they are also there. Now, by definition of what machine learning is, or first of all, what the whole, lesson is going to be, the objective of the lesson, let's ignore the first point. So in this section, we are going to cover some important theory and concepts surrounding machine learning. Right. The first point is more advanced, like TensorFlow, Keras. We don't need them here. Now, I will talk about what machine learning is, what deep learning is, theoretically, no mathematics backup, difference between supervised and unsupervised learning, supervised learning processes, then how we evaluate performance. We look at overfitting and underfitting. I think if you're able to understand these 7 points, it will be enough for you to able to explain what machine learning is in a more moderate level. Now, we also look at machine learning methodologies, right? Now, the whole idea of machine learning is that if you take traditional computer, we say that computers are electronic idiots, garbage in, garbage out. Whatever you give it to the machine, it's going to process the data and bring out the data. I think this is basic ICT. Right? The computer is electronic machine which accept data, process the data, then bring out the data as information. Now, that is how we know computers to be. In this case, machines to be. So, some people want to make it step further to say that, okay, we want the computer or the machines to learn as human being. So, how do we achieve so? So, that's the whole idea of machine learning. How machines can learn or mimic human beings, how human beings learn. And to be able to achieve that, they need to solve this issue with mathematics. And the whole idea of machine learning is those on matrices, a complex matrices. I think some of us we did it in SHS, complex matrices, but we will not need to look at it here. Now, machine learning is used in a lot of field. I think we've already know this, like fraud detection, web search results, credit scoring, prediction, new price models, customer segmentations, a whole lot. But then each one of them, if one each one of the used here is either a supervised or unsupervised learning. So the machine learning uses two approaches: the supervised and unsupervised learning. Even though I'm not sure it was mentioned in the class, I don't recall though. But you need to know what is supervised learning, what is not supervised learning. Even furthermore, we have reinforcement learning, which I'll explain all of them for you to comprehend. In traditional programming, in traditional programming, you what you basically do is that you when you input a data into uh, programming, like building a software or building anything program, right? This how it works. Okay, you input the data, right? So when you input the data, then you have explicit rules that you use. For example, if I want to build a software which has a login system, what I do is that when the user input the email and a password, I'll capture the email and password, store it in a variable. Now when I pick it, when I get those information, password and email, I will scan through the entire database to see that if the password exists, if the email exists in the database, but that's not enough. If they exist and they correspond to each other, because we can have an the email may exist, the password may exist, but it does not belong to that user. So you will still have to write those explicit rules to say that yes, if the password exists in the database and the email exists in the database and they correspond to each other, then allow the person access. So that is the traditional way, right? So input the data, explicit rules, and get an output. Now, this is how the machine learning also works. You input the data, then you have output labels, right? The output labels, that means you capture part of the data, then you put it to a learning algorithm. Now, this algorithm we are talking about has been already programmed by some top engineers. You don't need to worry about you bringing your own algorithm. This has been already programmed by top engineers. They exist already, right? Then you put it in the learning algorithm. The algorithm learn through the data that you've provided. Then it build the model. Then it what gives you prediction. So that next time when you come with similar data set, the the machine does not go over the process again because it has learned now. Traditionally, it does not learn. It doesn't know anything about learning. So it just go the normal flow. But when it learns, it's able to detect that okay, this structure has passed through me before. So let me use it that way. So machine learning is used for a lot of things that we already know. Now, every day we meet different ways and different terminologies. Anyway, pardon us for that. Now, we are going to look at what are neural networks. Is there a question? Yeah,
Yeah, more.
yes.
Yeah, so what basically you're trying to say is that with algorithms, um, before you can apply an algorithm to your data set to learn and give you an output, it means you need to understand those algorithms because you cannot just apply any to get the 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 results that you want, right?
Exactly, exactly.
So the question I'm sure the other colleagues on the call will, how do you know which right algorithm to apply?
All right. So how do you know which algorithm to apply? Now,
Because you mentioned that this algorithm that has been already been
built.
programmed.
Yes,
Exactly.
yes. How do you know which algorithm do you apply? It's a very important question. Now, this machine learning is not magic. You need domain knowledge to aid you to use machine learning. Now, if you give me a task in the field of, let's say, law or jurisprudence, honestly, how I will use machine learning to achieve the results will be a challenging thing. That's not my background. If you give it to me in finance, that's not my background. But then if I have the same knowledge with someone from, let's say, finance or law, and we have to use the same tool to achieve a result, You see, the person who will be able to produce a better result than me because of domain knowledge, right? So you first of all have to understand the data set you are going to deal with, the problem you are going to solve. What do you want to achieve? That will help you to determine which model are you going to use in the first place. And now in the machine learning process, as learning, I mean your learning path, you use a lot of tests. You test with a lot of data data set. So in our case, in our class, we use Yahoo. The last week we used Yahoo dataset. I think it was around November. Sorry, November December 2019 dataset, right? And it is a time series. How do we know it's a time series? Because of the date range in it. So if you don't know that it's a time series, you cannot come up with the output. So in the learning process, you'll be taught all these things. You will deal with what is classification data set, what is linear regression. So once you have a problem, you are able to know that okay, this is how it's done, right? So you don't just wake up and feel like okay, today I just want to use machine learning to predict something. So you learn it in the learning path. For example, that's what we are doing. So part of my goal is that we are going to use two platforms. One has AI in it, and AI to help you use machine learning. That one is very easy, right? Aside that, we also look at what they taught us in class, right? So we will look at a platform called Google Code Labs. So we use the same data, prepare the data set on sales forecasting. We use the same data set in the AI studio to achieve a certain results. Then we use the same thing in the Google Code Labs to achieve the same results. Yeah. So you need to have insight of what you are doing before you are able to determine the the algorithm you will use. Right. I don't know if that helps answer the question. So back to it. Neural networks. Now, so for some of us, this is a new word, but let me break it down. When we say neural networks, it got its motivation from how the brain works, neurons. You know, they are very fast and they are connected to each other through nodes, right? They are connected to each node and they transmit information very fast. So that's where they got its motivation from. So instead of having one entity or one, let's pick one algorithm A, and it goes on only one node. We have, I mean, few nodes that connects them. So it makes transmission of information and processing of information faster as as compared to having one node. So when you say neural network, first of all, look at it as the brain, how the human brain works, how they transmit data between each other, right? Now, we use this neural network to solve tasks that that are not so simple. For example, image classification. For example, if I have an example I used last weekend, if you have pictures of cats and dogs, right? How do you solve this? You know, it's not like a forecast. It's categorical data. So that's when neurons comes in, right? Neural network comes in. So we have set A, which has about 1 million different types of cats. We have set B, different types of dogs, right? Now, you feed this in an algorithm. The algorithm is built with neural networks. So the algorithm is able to take the pixels in a form of mathematical representation, which we don't need in this course, this MSc. So it picked them in mathematical representation, then it stores it. Now because it's using neural network, it is faster, right? It is faster. Now one is able to do so, and later it learns. Later, if you bring any picture which was not part of the picture you learnt it, maybe you take a fresh picture of cat and put it in the algorithm, because it has learned about 1 million data set, it is able to tell you in a faster way that this is a cat or a dog, or it's none of them. So over here, the larger your data set, the higher accuracy you will get. So if you feed your algorithm with, let's say, 50 set of data, and someone else feed you with 1 million set of data, the person with 1 million set of data is going to have high accuracy of better results than yours. So machine learning or the whole AI thing is built with data, right? So that is the motivation behind the neural networks. Now, what is deep learning? Now, deep learning refers to the use of neural network, but then with a different layer. Instead of fewer of them, this one is a lot of them, and it requires high computational. Mostly our basic laptop cannot process with deep learning because it's more powerful than neural networks, right? So I hope I was able to break it down for you to comprehend. Any question with regards to neural networks?
Me, I'm okay. It looks like we are even covering more than what we already knew from our classes, and I don't blame you because of the limited time.
Time, exactly, exactly.
At the time, yes. So.
All right. So we have two types of machine learning. We have supervised learning and unsupervised learning. And in advance, they tell us we have reinforcement learning. Even though most of all algorithms that are out there are reinforcement learning, it means that it enforce the algorithm to keep learning. It never stop learning. It keeps learning by itself. And I think that is the aim of the whole AI industry. We want to get to a point where we have artificial general intelligence, where artificial intelligence is able to complete certain tasks without human intervention. At this point, AI is not able to do most of the works without us. But then scientists and academicians are still working around the clock. So we will look at supervised and unsupervised learning. All right. Now to
So,
break it,
Mo, which of this type did Dr. Tachi took us through?
he was talking about supervised learning.
Okay, all right.
Yes. So we have um in basic definition machine learning, I mean automated analytical models, neural network, a type of machine learning architecture model after the biological neurons. Then new deep learning is the same neural network but with more than one hidden layer. It means that it has multiple layers which are more powerful than neural networks. But sometimes in tech, right, we said that we don't use a hammer to kill a mosquito. Some tasks can be achieved with normal machine learning. You don't need to go and use deep learning because we have what we call computational power. If you want to solve any problem computationally, we are looking at efficiency and effectiveness, right? If you can solve a problem easily with machine learning and you can solve the same problem with deep learning and to achieve the same results, it is better to use machine learning because if you go and use deep learning, you are going to waste more computational power to achieve the results, right? So you need to know how and where to achieve. But some problems too, you will need deep learning. Machine learning will not be so easier. So we start with supervised learning, right? All right. So supervised learning algorithms. These are trained using labeled examples, right? So for example, we have an input where the desired output is known. For example, if you pick a data set of a particular supermarket, now the data set, let's say a data set from 2020, let's use Paradise Supermarket for example, Paradise Supermarket. Now they will pick their past sales from 2020 to let's say 2025. The items they saw, the benefit, whatever they got. Now we want to predict that in the next year, in 2026, they are able to make this particular revenue. We are able to do so because of the past data we've collected. Now that data set, we have certain elements, certain columns. Now the data set, think of it as in Excel. For things to be easier, think of the data set as Excel. We have certain columns in the Excel sheet that are so important that we have to look at them so it is known. We know that table, and we know our output in the sense that we are expecting what a positive or negative, nothing in between. For example, a segment of text will have categories such as maybe spam or legitimate email, positive or negative, 0 or 1. So the key words here is that these algorithms are trained on a labeled examples, and the output to what the desired output is what already known, right? Good. Now, how it works is that the network, in this case, neural network, for example, receives a set of input along with corresponding output. And the algorithm learns by comparing its actual output with correct output to find errors. Then it modifies the model accordingly, right? So one of the data sets in the practice we will do is that we will look at emails that are spam or not, so that it will give us more insight, but not today. For now, I want us to get the basic understanding. So in basic terms again, we have a data set. For us to know is supervised or unsupervised. We supervise. We have input that we receive from the data set, and we have a desired output. So for example, either it's a spam or not, either it's 1 or 0, either it's yes or no, right? That's the example of the basic definition of supervised learning. So supervised learning is commonly used in application where historical data predicts likely future outcomes. Like the example I used in the sales, like the paradise sales. You pick past data, then you can predict the future. Now, this part is very important. If today you did not learn anything, please learn this. Please, if today you are not learning anything, you should know this if you live here. Now, how machine learning process is done. These are 5 models or 5 processes. The first process is data acquisition, where you acquire your data. It's very important. So you can acquire your data through online, through a lot of mediums. So when you acquire the data, we will look at data cleaning. How do you clean the data? What do we mean by data cleaning? Sometimes there are some impurities in the data, missing values, error in the data set. So let's say you have a data set that has about 1 million rows and columns, a large data set, then a lot of errors in it. If you don't clean the data, it affects your final output. So that is where data science plays a vital role. So in data cleaning, that's where data science really come in. So for example, in Python, we have something called null values. Null values are like values that do not exist. So I think doctor asked a question last weekend and he gave a perfect answer. He said that whenever you have a data set and it's empty, some fields are empty, the machine learning will not work. It will stop because it wants to learn what is there so that it can aid it in the future. But if it is not there, it can't learn, right? So if you have a data set, there's now values in it. What you can do with Python is that you can say fill now all the now values, put 0 there, or put the mean of the above number and also the next number, or interpolate. We have a lot of ways to fill it. When we do get to the practical session, we'll look at those examples. So once you acquire your data, you need to clean the data. Make sure the data is ready to be trained in the model. Now, after cleaning the data, then we go to model training and building. More is more of training. Our level is training. We won't build. We are not going to build our own algorithm, not at all. We can actually build our own algorithm because most of the algorithms are how do you call it? They are open source. You can contribute it. Now, And that's why we have a lot of people building a lot of AI startups. So most people ask them, how do they do it? They don't reinvent the wheel. They have existing model, and they can add up. For example, we call something RAG, right? Augmented, algorithm. So what we do is that, let's say ChatGPT, for example, it is LLM. Whatever command, whatever question you ask ChatGPT, it gets an answer for you. But then maybe you want to train ChatGPT to be only asking questions in Ga. How do you do that? So you can go and pick the ChatGPT model. You have to pay through API. Then you train the model specifically for Ga. But you need to have a large data set so that when then you can name it your own way, so that when people put questions to it, it gives the answer in Ga. So if what build it, but not from scratch, you build upon existing one, then you just pay them and you are good to go. That's why a lot of people are building a whole lot of AI startup, and they are winning. So the algorithms are there. They don't build anything from scratch, because the engineers that build this algorithm, they are top engineers. It will take you years to build your own. Even how to host it is another issue. Now, after we will deal with more of training of the model. After the data set is clean, you pick it and put it in the model, right? Now, when you put it in the model, the algorithm learns the patterns in the data set. So when it learns the pattern, then you test the model. So you look at some of the way to test the model, like the mean square, mean R square, all these things. You look at it. It's not so difficult. For first time, you may think this is ambiguous, but they are very simple. So when you test the model, then you get the desire you want, right? Then you deploy the model. Deploy means that bring it to production. You start using it. But then if you're not okay, then you go back right after the test. You go back and clean the data. Sometimes maybe there are still certain impurities or certain things you didn't do well. Then you go back and do it again, right? So from here, if it is okay with you, you deploy it. If it's not, you what? You go back to, sorry, go back to model training, right? Then you still go back here. So you can just repeating this. There's nothing so wrong, right? So data acquisition, you can get your data from customers, sensors, a whole lot of places, right? Now, you clean and format your data with pandas, which is Python. It is very, very cool. It's so interesting. I think yes, we will look at it in the practical sections. We will look at it. But we see with Art Studio, you don't have that option. So if you look at the data set that Tatichi gave us, it has no impurities, right? It has no zero. All the columns were filled, right? It was in the process of training the model we saw that some question marks were elsewhere, and he showed. So I was even hoping that the data set could have some missing values. Then we see how we can solve with the Alta Studio with that, right? I don't know how it is done, but with Python it's so easier to achieve it. Ehen. Then we also have the testing, the same process. Yeah. So supervised learning, we just show you a simple approach to supervised learning. It contains an issue. So what I want to build upon here is that now the supervised learning is okay for certain problems, but then it's not okay for other problems. So our next chapter is going to introduce us to something that is actually huge, right? That we will need. Now, is it fair to use our single split of data to evaluate a model performance, right? So let's say we have data sets. What actually happens is that we have a lot of columns. Not all columns are relevant to to use in achieving your goal. You have about 50 columns, probably maybe customer name, right? Customer name, customer house number. It does not have a direct impact on the output. So that is why we have what we call feature selection or feature engineering. We will look at it. Sometimes when you're building the models, you have to ignore certain columns. You need to select the features that has a direct impact. So that's why we have dependent variable and independent variable. We'll look at all those things, theory and also in practice. Uh-huh. Now, so now when you have a data set, right? When you have a data set, like I said, you cannot. So let's base on this question. Is it fair to use as our single split of data to evaluate our model's performance? Is this really fair? Now let's look at how we can answer the question. Now to fix this issue, data is often split into three sets. We have training data, validation data, and test data. Each one of them is very important. Okay. Now we use the data, the training data, we use to train the model parameters. We use to train the model. And this data is mostly very large as compared to the rest of it. So let's say if you have about the 1 million data set, you use 70, or let's say yes, you use 60%, for example, use 60% to train the data, right? Then you use let's say 30% to validate the data. Then you use the 10% to test the data. But if you use, let's say 10% to train the data, then you use large portion percentage to test the data, that's why we have overfitting. Because I said earlier on, the whole idea of machine learning depends on the large data set. The accuracy of your model depends on the large data set. Because if the machine is able to learn a lot and we give you fewer, it's able to, detect it. So we split it mostly into two or into three: training data, validation data, and test data. That's how we split it. So this means that after we see the results of the final test, we don't go back and adjust any model parameters, right? Because already we have a large data set that has been trained and is able to take a small amount of data. Then we are really, really okay with that. Now, this final measure is what we label true performance of the model. All right. So in this course, right, what we use was we have the general way. We have train and test split. Train and test split. So if you remember the data sets that Dr. Techi gave us, we had two, right? We had train and test. So we're using the train data to do the training. So at the end of the day, we're supposed to use the test to test the model to see the performance. So mostly we have train and test split. That's how we have the data set. But some people use train, but then normally we use two. Yes. And the train data takes 70% and this test data takes 30%. Please, any question? Any questions so far? Are you guys with me? Am I talking plenty?
Mohammed, I want to ask a question.
All right.
So during the Saturday class, did we use just one data? Because myself, I was confused. I don't know whether it looks like we used the train data. Did we ever use the test data?
No, I don't recall.
We didn't use it.
Yes, we didn't use the test data.
So at which point after using the train data would you need the test data?
Yes. So after, let me go back to the processes, right? So after this point, right? After this point, so the model training, after building the model training with with the train data, when you're about to test the model, you use the test data to test it.
Okay.
So that's what we didn't do. We were able to train the model, all right, but we didn't test it, and we ended the class. So if we were going to test it, that means we use the test data instead of the train data. And the train data,
Mm,
yes. So if you look at the size of the files, you realize that the train data was more than the test
it's
data.
bigger. Yeah.
Yes.
Okay. So I want to know it. Hey, who is that in the spirit?
Madam Patricia, Do you want to ask something, madam? Okay, you go ahead.
Yeah, yeah, I was asking something that I somehow missed that family.
You have a great time.
When I remember, I'll ask again.
All right, sure.
The thing distracted me,
All
so
right, sorry about that.
that's
I'm
okay.
sorry, oh, it's not even me.
Oh, that's
It's on.
okay. That's all right. When I
It's
remember,
on.
I'll ask.
Okay.
All right. Please, any other question before we proceed? But are you sure everybody's here? Some are not just here and you're sleeping. Please, if you all have questions, let's ask. It will help us to get things done well.
Yeah, for me, I might have to engage you.
Madam Patricia, I can't hear you.
Mohammed, it's not easy like that. So what we are learning is very confusing.
Yes, it's not easy.
So it's very, very confusing. So some of us we are just going by what you are asked go do as you go. I'm just wondering that on Wednesday, how is the exam going to be like? And I
Are
was
we
just
writing the
wishing
exam on
that
Wednesday?
yeah, definitely, because it's like the last class.
Oh, we will do it. We will do it. Don't worry, we'll do it
Do
together.
what? I
But
didn't attend the class. What?
Don't worry, we'll do it together. Since we have a common platform now, we'll do it together.
Hey,
so
God.
Yes.
I want to know, Mohammed, now that we don't have the notes, all we have is just the recording that was
Yes.
shared. And sometimes, because Dr. Techi is already he already knows what he's teaching. And I mean he goes by, but then as to the notes in itself, is there any way we can get to probably have some small discussion on it before he does the test on Wednesday?
And the
Because
time
on a more serious note,
on the time
myself, I'm really scared.
on
No,
the
so Elizabeth, so what's going to happen is that with the test, the in class is going to be, it's not going to be a practical one, right? It's going to be like the
all right. So let's look at underfitting and overfitting. In the first place, why underfitting and overfitting? The reason is that sometimes if you are not careful with the cleaning of the data, taking the impurities or following the actual process or picking the right algorithm, you are not able to get the best results. So we use this overfitting and underfitting to determine the accuracy of our model or the results that we want, right? So it has some mathematical stuffs which we will not look at. Probably we'll look at the graphs, right, of the relationship of what is meant by underfitting and overfitting and how we are able to reduce it. Okay, I think Dr. Techi mentioned one way, which was taking the natural log of it. So when we say overfitting, what is overfitting? Overfitting is when the model fit too much to the noise from the data. What are noise? So noise are basically the errors in the data set, the the impurities in the data set that we could not get rid of it. Now, this often results in lower error in training data set, but high error in testing data set. So you were not able to fetch out most of the errors in the training data, but on the test data you had less error in it. But so it will cause a confusion, right? So that is why clean the data set is so important. The data cleaning is so important, and that is so much of data science, right? So that's basically what overfitting is. We will look at graphical examples of graphical explanation of it. Now, so let's say you have a data, right? And we have is a y against x in this particular point. Now, what we mostly want to achieve with data science is
Mohammed,
yes,
Mohammed, yeah,
yeah,
this Aaron. So I want to simplify this. See,
yes,
that's how I learned. So pardon me. So the overfitting means it's like you are confiding the machine, right?
yes,
It's perfect that the machine cannot learn.
Yes, but you are
Okay.
forcing you put certain strategies that the machine overlearn.
Okay.
You understand? For example, if you don't take out the impurities in the data set, the maybe large values, maybe you are recording sales, right? The average sales for that particular supermarket is mostly like 100 cities. Then one day you have 1 million Ghana cities, which may be an error, but then you overlook it. You understand? And you have a lot of them in it. You overlook it. So it's going to make the model like nearly perfect. It shouldn't be so. So it's overfitting. And so when you ignore those basic nuances in the data set, it causes a problem. Are we good to go?
So Mohammed, it's not that if I want to rephrase what you said,
Yeah.
it's not that the 1 million is an error, but it's like a one-time event that doesn't often occur. Is
That
that what you mean?
so it can be an error, one. It can be like
Mm-hmm.
it occurred. But then in such scenarios, you have to find a way to reduce those particular values so that they can have a basic trend, right?
Okay.
That falls under the cleaning of the data. So you need to have insight of the data, right? So mostly what happens
Even Mohammed, even though it's not an error, let's say
yes,
the scenario,
even though
you
it's
still
not an
have to
error,
correct it.
yes, even though it's not an error,
Mohammed, I understand you.
yeah,
There's a peculiar example that we have in our workplace.
yeah,
So, for example, if this year I was given a target of bringing in, let's say, 20 million at the end of the year, and one of my customers gave me, like, let's say, 50 million. And so by the end of the year, I ended with 55 million instead of the 20 million that I was asked to do.
yeah,
That would mean that I've exceeded my targets by nearly 35 million.
yeah,
So, under normal circumstance, when they are setting the targets for next year, they should probably pick an average value and not build on the 55 million I brought in because it was a one time deposit that I received.
exactly,
But instead of them going back to the 20 million and possibly adding about, let's say, by or large, another 15 million for me to do for the next year, they would rather build on the 55 million. Until now, new year and year best starting, I'm never able to meet my targets
yes,
because they built on my targets based off on the one-time events that occurred in the previous year.
yes. And
Is
you
it
know,
something like that?
it's something like exactly like that. So you know that the
Okay.
machine learning uses pattern. So it has stated a pattern
Mm-hmm.
that this is the average that occurs, right? And we
Okay.
have fewer of them that is doing so. So it will cause a problem.
Okay.
So in such scenarios, what we do is that we find a mean. There are a lot of statistical approaches to this. Yeah.
So that means it's an outlier, right?
Outliers. Exactly. That's the term we even use in machine learning.
Okay.
Outliers, yes. You really need to
Okay.
consider them, yes.
Thank you so much.
You're welcome. Ella, I didn't know it was you. It's not that I'm getting the voice.
Oh, it's me.
Oh, this one there.
So you see, we have a data set like this in this graph. Now, mostly what we want to achieve is that say you the line FM say you person point no very far from the line. So that line no, we call the line of best fit. I wish I was on the board. Also our point we say the line FM say we don't want this point to be far from the line, and that is the line of best fit. So when the line is there, there is a line, and these points are far from the line. There's a way. It means that our model is not really doing well. So how do we do? There are a lot of ways we look at it in the practical session. Let's say this is the line. This means that it's a good model because the points are not so far from each other. This is a good model. Good. Now we are looking at overfitting. So overfitting is like something like this. Your line no crooked. It have to sorry, let me explain it very well. Overfitting will like it will pass through each point. the line will pass through each point, meaning that it is fine, everything is perfect. If you look at the good model here, the line is passing through the point, all right, but then not all of them, and they are not really, really far, right? We will look at underfitting, then we see that the points will be far from this green line. So this is a good model. But overfitting want to tell you that everything is nearly perfect. The line of best fit is nearly perfect. So it
Mohammed,
yes.
Mohammed, sorry, I'm trying to recollect my course. So with what I've seen, okay, it
Mhm.
means the good model has some margin of errors, right?
Yes.
Yeah, the deviation from the line, they are the margin of
They
errors.
are the margin of
Yeah.
errors. Yes.
And overfitting is trying to tell us that it's too, so perfect that there's no error.
There's no
Error,
error at
yeah.
all. There's no error at all or
Okay,
limited error.
great.
Yes.
Okay, great.
So it passes through each particular point, right? So that's basically how to explain overfitting with this graph. So you see over here, it's still overfitting, even though this line was not touched. So you understand. So it's still overfitting. So the point from this line to this is the margin of error. That's point. Yes. So whenever we have underfitting, we can use the natural log. Because it means that the values closer to the line of benefit are far. So how do you minimize it? So there are a lot of statistical stuff I use. Yeah. So underfitting a model, right? Or underfitting. Now models do not capture the underlying trend of data and does not fit the data well enough. For example, low variance but high bias, underfitting is often results of excessive um simple model. So sometimes you are biased. You become biased, and that is one thing that they always advise data scientists. You should not put your emotion in the results you want to get. Obi wɔ hɔ a ɔpɛ sɛ kyenkyena atwan ɔnyɛ saa results wei by force he's supposed to get this particular results. So he add emotion even if the model is telling you this, you still don't want to accept it. If you have to do approach to get things right, they want to try to bypass it so that at the end of the day they made it. So mostly you get underfit. And a clear example is when you use about 30% data to train the model and 70% to test it. Definitely you get underfitting because model no wasua nneɛma kakra bi, he learnt only small and you are testing with something bigger than that, right? So obviously you get underfitting. That's one major cause of it. Now, so let's look at the same approach. We have the data in this way. Now, this is underfitting. So you see, for example, even though these points are closer to the line of best fit, but look at this line, this dot, and these guys, these three ones, even less, these four, they are far from the line, right? So they are underfitting. But overfitting, the line passes through all of them. So if you run a model, mostly in regression, and you get your results and you see that okay, point is far away. It means that your model is underfitting, right? Now, some of the things you can do is that this data was easy to visualize, but let me put this guy down. But how can we see underfitting and overfitting when dealing with multi-dimension data set? So some data sets are more advanced than the other. For example, the one we used in the class was a basic one. We didn't have much, we didn't have much columns, no sub columns, and the whole thing. So we also have multi-dimensional stuff, which I don't think we'll talk about it now. So, but then this lectures give some few examples we look. So, always if you want to check if a model is good, we have something like this. The error goes up and the epoch, honestly, this thing I don't understand. I don't know this guy. All right, these two guys, honestly, I've forgotten. Let's look at this thing. Now, when we are looking out about overfitting and underfitting, now what you have to keep in mind is that the relationship of the model performance on the training data set versus the test data set. That's one key thing you have to look, like I said earlier. The relationship between the data set of the one you use for training and the one used for test. Now, if, for example, you don't have any impurities, you don't have any error, there's no now values in the data set for the training, but on your test data set, you still have errors there. You still have issue of either underfitting or overfitting. That is why cleaning of the data is so important, and acquisition of the data. Those parts are very crucial. Yeah.
So, Mohammed, let me ask you,
Yes.
with this two set of data,
Mm-hmm.
we have the training and then the test, right?
Yeah. Yes.
From the one we did over the weekend, we only went through the training, if I'm
Yes.
not mistaken,
Yes.
right? We didn't go through the test. And the training had about 1,008 something, 855,
Yeah.
while the test was just 385 or so,
Yes.
right? So just like what you just mentioned, what if the tests also have some margin of errors? Does it mean that you have to go over again and train it again, train the data to, bring out those errors to be fixed, or how that? What is the relationship between the two? How, at what point do you use the test after training the data?
Normally, what happens is that test data are done without or are prepared without errors, but it doesn't mean it can't have error. It depends. The result depends on the data sets you use for the modeling. If everything is right, even if the test data has issues, it can be minimized or negligible. It can be small, right? But then if you ignore those nuances, if you ignore those errors, thinking that they are not so important, and there's a small amount of error in the test data, it means that there will be a major error because there are two errors in both, right? So you have to look at the trend data very well. If we're able to pass through all the rightful procedure, make sure that the data is really good for the model, and you choose the best model for it, it means that when there is an error in the test data, it can be minimized. But if not the case, you find yourself into a big issue.
Okay, all right.
Yes. I don't know. Let's add. Can we add one section before we go? This is very important.
Yeah, yeah.
Yes.
That's good.
All right. So we are looking at evaluating performance. After everything, after you train the model, after you put in the prepared data set, everything, after getting the results, how do you evaluate the performance? How do you say, okay, this is good, this is not good? I have to go back and start all over. So we have in classification, we have things that we need to do. We have so many things we need to understand. We have what we call accuracy. We have recall, precision, F1 score, um, mean R square, and those things. I think Dr. Techi was mentioning them. So these are how we evaluate our model to say that okay, we had this particular percentage. So it means that the model is good. It's performing very well. So if it's outside it, then it means that there's a problem, there's something we need to, look. So this will be the last thing we'll look before we close for today. All right. So first of all, we the lecture is saying that we should first understand the reasoning behind these metrics and how they are actually work in the real world. So these are statistical stuffs, right? Now, typically in any classification task you model, your model can achieve two results. Either your model was correct in its prediction or your model was incorrect in its prediction. There's no two ways, right? They are mostly correct or incorrect. Now, fortunately, incorrect versus correct expands to a situation where you have multiple classes. For the purpose of explaining the metrics, let's imagine a binary classification situation where we only have two variables. So in our example, we will attempt to predict, oh, okay, this is I think this particular lectures I remember we did something in the course. So this course was a video recorded course. So I think we cannot follow this. This is what I want. All right. So I want us to focus on these guys. These ones. These are how we use to evaluate our model, right? But I think the lectures we use a particular example, but because we are not using that example, if I explain, I'm not sure we will really get it. Yeah. But what I do remember in the course was that we have this particular train model, then we have test image, right? The data set we used was called S underscore test. So we inserted this into the train model, right, as a new picture, right? Now it predicted that this is correct label because it has been trained with a lot of data related to dog. Then it predicted that image is a dog, right? This is a correct. So dog is really correct, right? Then when you go further, it is not a cat, right? Because the model has been trained very well. So if you put any virgin picture of dog or cat, it's able to determine, right? Now, if you look at accuracy, these are part of the model evaluation method. Now, accuracy is basically classification problem. We cannot use this in linear regressions like time series. This is for classification, whether this belong to this or this belong to that. Like for example, what we just said, the cat and dog. So that the accuracy formula is the number of correct prediction made by the model divided by the total number of predictions. So if let's say the model was able to predict about 100 predictions, now we take the number of the one that were corrected divided by the number, right? So we can say n by let's say f by n, where f is equal to the number of correct prediction and n is the total number, right? So that's how we are able to get our accuracy. So it will give us in a percentage wise. Let's say you have 100% pictures, right? Then at the end of the day, you get 80 prediction to be corrected. It means your model is doing very well, right? So that's the accuracy. That's one way we evaluate our model. Now, so for example, if the test was 100 images and our model correctly predicted 80 images, then we have 80 over 100. So 0.8 or 80% accuracy, which is good. Now, accuracy is very useful when targeted classes are well balanced, right? So if the pictures um, has only cats and dogs but doesn't have any other, it means that the likelihood that you get accuracy in a good way is high. So example that was used, we would have roughly get the same amount of cat images as we have dogs. Yeah, the same way. So accuracy is not a good choice with unbalanced classes. So imagine we had 99 images of dogs and one image of cat, right? So that's a bias, right? So let's say the data set that we had more images of cat than dog, right? It means that the model will not be able to know much of dogs because it only have few of them. So it means that it also give us underfitting in the case of cat. But in the case of dog, it will give us sorry, in the case of dog, it will give us underfitting because we have, let's say, only one image. But with cat, it give overfitting. So we always have to look at the balance of the data set. Yes. Now we have another way to evaluate our model, which is recall. Now recall is the ability for the model to be able to find all relevant classes within the data set. So this makes the machine learning more different from the traditional way. It's able to recall that I've done this before. I've been trained with this before, so I can recall, right? So the precise definition of recall is the number of true positives divided by the number of true positives plus the number of false negatives. Let me explain that very well for you to understand. Let me get an image from Google to explain it. So Doug was explaining about confusion matrix. Do we remember confusion matrix? Nobody remembers confusion matrix. Yes, in ML. I want an image to explain. We have type 1 error and type 2 error. Please, this one there you should just know. Is there a question? Wow, you say I cannot share my screen. Oh, I should use paint to draw. Okay, this wants a picture. Okay, this is fine. Right, this is fine with me. Hold on, let me share my screen. We have the confusion matrix, and it also helps us to do a classification evaluation to evaluate a classification problem. Then we have type 1 error. Can you see my screen? Hello, are you with me?
Yes, but I can't see the screen. Okay, it's okay now.
All right, that's fine. Good. So what we are saying is that um, we have a confusion matrix like something like this. We have true positive, and we also have false negative. I think there are four, right? And they are mostly important. We use it to evaluate the model. Now we have predicted positive and actual positive. So let's say the model is able to tell us that the picture of a cat is a cat. That's what we want to achieve. The picture of a cat is a cat. So that is true positive. The predicted negative, it means that it tells us that okay, it is not a cat, but then it is a cat. The predicted outcome is saying that it is not a cat, but actually the picture is a cat. That's type 1 error. Good. Then we have actual negative. The predicted is saying that it is what? It is false. Meanwhile, it is true. So that's type 2 error, false positive. Then we have true negative. It is predicted negative and actually too is negative. So we look at the diagonal nature of the confusion matrix to determine, right? So this is type 1 error and this is type 2 error. Yes. Any question? All right, awesome. So let me come back here. Good. So to use the recall, the precision the precise definition of recall is that the number of true positives, okay, divided by the number of true positives, which is mostly is going to be 1. So let's say you have true positive of 5, right? Divided by 5 is 1 plus the number of false negative. That's the type 2 error. So you add it, you're able to get your record. The good part is that with Python, you don't need to put this formula. The record is already there. It has been implemented. All you have to call it as a function and use it. But then you need to understand the logics behind it in case you want to supervise someone in future. So don't worry if you don't really get these stuff. It's not really meant for you. Your point is know that we use recall to do evaluation. Yeah, that's what I want you to understand. So don't put so much concern into how it is being done, but just know that we use it for model evaluation. Now we have precision. So ability of a classification model to identify only relevant data points, right? So precision is defined as the number of true positive divided number of true positive plus the number of false positive. So it's the same approach, just that this one uses the type 1 error, right? So this divided by this will always give us 1, right? Then plus the false positive, that's the type 1 error. Now we should also know when and where we should use recall or precision, right? So often we have a trade-off between recall and precision. So for example, in a case we should use recall. Recall expresses the ability to find all relevant instances in the dataset. Like I said, sometimes a lot of things in the dataset might not be needed. Certain things are actually needed. So the record will put concentration on it. The precision express the proportion of data points our model says was relevant, actually were relevant, right? So it's the proportion. But this one look at what is actually relevant. Okay. Now we have F1 score. Now F1 score is the ultimate. I really like it. Now F1 score is where you find optimal blend of precision and recall. So we can combine the two metrics using what we call the F1 score. F1 score is mostly the final thing you determine your model evaluation. It is the we combine the two metrics, right? That is the precision and the recall, then that will give us the F1 score, right? So this is the formula used. F1 is equal to 2 times the precision multiplied by recall over precision plus recall will give us F1 score. This formula you will never use it in anywhere, but then because everything has been already programmed for you, all you need is to know that we use F1 score to achieve this. So don't worry so much about it. Yes. So this is the confusion matrix once again to use to know type 1 error and type 2 error. So I think we'll end the lessons here. Probably next time we meet, we'll look at this particular platform, um, Google Colabs. Let me see. But before we use Colabs, I'll walk you through this thing again, the the studio. I think I've, I was even doing something last night with the AI studio.
Yeah, me I did something.
Yes.
But just like you mentioned, maybe we can also explore other options that maybe the teams may be because the studio Dr. Tati used to us is not the only machine learning platform that you can use to do some of this
Yes.
analysis here. So there are some that come with
Google
some
Colabs
issues.
is very
Yeah.
cool. It's really cool. And it uses AI to help you. You can use AI to aid you to do whatever you want to achieve. It's very cool. All you need to know what you are doing. The AI will suggest, should I do this? Then just yes, and you are good to go. So this time we don't really reinvent. And
Mm,
there's also Julius UI. So yes, Julius AI rather used to do a whole lot of
yeah.
things. Yes. So I think we'll get the best out of it of this class. And also with blockchain, I'm hoping
What's the new Google Watch? Can you
yes.
put it in the comment section more?
Let me send it in the group. Let me send it in the class group. Google Collapse. Okay. Yeah. Yes.
Mohammed, can you hear me?
Yeah, I can hear you, sir.
Mohammed, can you hear me?
Yes, I can hear you.
Yeah, yeah, good evening.
Good evening.
Good evening. This is Ebenezer.
Aguba, I can, I
Hey,
can,
do
I
you
can,
per
I
do
kind
you
of
per
record your
chance
voice.